Right. Hi students. In this video, what I am going to explain you is the total probability. Total probability. Yesterday, I uploaded a video on Bayes theorem, and in this video, I am going to explain the total probability. After that, I will do some questions under total probability, and at the end of this video, I will explain you the probability question that came in 2019 A-level combined mathematics paper. Okay, so to make you understand the concept of total probability, let me take a simple example. Okay, so let's consider we are going to take an example of a classroom. In a classroom, we have boys and girls. Okay, boys and girls. Right, now let's assume there are 100 students in a classroom. Okay, and out of the 100 students, we have let's say 40 boys and 60 girls. Okay, so in a classroom, some students might wear spectacles. So I'm going to take, so both boys and girls might wear spectacles, but not everyone will, not all the students will, only some amount of students will wear spectacles. So I'm going to take this portion as the students wearing specs. Okay, right. Now let's assume out of the 40 boys, only 5 wear spectacles, and out of the, okay, now let's say 12, and out of the 60 girls, only let's say 30. Okay, most of the girls wear spectacles. So let me take 12 boys out of 40 boys wear spectacles, whereas 30 out of 60 girls wear spectacles. Now I have to find out the total probability of wearing spectacle. Probability of wearing spectacle. So this is actually called the total probability. Now what I can write here is probability of wearing spectacles when the student is given as boy into probability of boys. So this is the equation. This is how we have to write the equation for total probability. Plus, okay. So now what we have to do is this portion. This portion is what? Now, the total probability of wearing specs when the student is boy into probability of boy, plus I will convert this scenario into tree diagram and explain so that you can easily understand. Now, let me write the equation directly. Plus, now probability of wearing specs when the student is girl into probability of girl. So this is the equation for the total probability, right? Okay. Now, let me convert this scenario into tree diagram. Okay. Right. Now, otherwise, before converting this diagram into tree diagram, let me think like this. Okay. Probability of wearing spectacle when the student is boy, given that, or this is like a conditional probability, right? So, wearing spectacles when the student or when the student is boy. So, what is the probability of this one? So, boys, there are 40 boys. There are 40 boys. Out of the 40 boys, 12 wear spectacles. And what is the probability of boys? So, out of the 100 students, we have 40. 40 divided by 100 plus. Now, probability of wearing spectacle when the student is girl. So, out of the 60 students, we have 30 students wearing, 30 girls, female students wearing spectacles. Into what is the probability of ladies in the classroom? That is, out of hundreds, we have 60. Okay. Now, what I am going to do is, I am going to just pick a student from the classroom. Now, sex-wise, the student might be boy or girl. Now, if I pick a student from the classroom, I can check whether he or she has worn spectacles or not. Okay. So, let me take this as spectacles and this is no spectacles. This is spectacles and no spectacles. Right. Now, what is the probability of being a boy in the classroom? Okay, that is out of the yeah, out of the 100 students, we have 40 boys. and out of the 100 students we have 60 girls. Now, if I take a boy, what is the probability of wearing spectacles? That is, out of the 40, now if I take a student, if I take a boy, the total number of boys are 40, and out of the 40, only 12 wear spectacles. So, this is how I am going to write in the tree diagram. And if I take a girl, that is, out of the 60, 30 might wear spectacles. Now, to find out the total probability of wearing spectacles, I have to add this portion and this portion. Actually, the total probability, the equation for the total probability can be easily written from tree diagram, right? Now, if you look at this one, okay, so 40 divided by 100 into 12 divided by 40 into plus, okay, we have to add this portion and this portion. So that is 30 divided by 60 into 60 divided by 100. Okay, so this is actually the total probability, right? So with this idea, I am going to explain you some more questions. At least I will explain 2 questions. After that, we will come to the 2019 A-level pass paper. Right. Now what I am going to do is, I am going to take 3 cities, right? So 3 cities suffer from, there are 3 cities, okay? There are 3 cities. These 3 cities suffer from pollution, okay? Right. Now pollution. Now this is city X, this is city Y, and this is city Z. Now all these 3 cities suffer from pollution, but the level of the pollution might be severe. So I am going to take this portion. So let me use a different color. Right. I am going to take this portion is the severe pollution. Okay. So severe pollution. Right. Now I have to find out the probability of severe pollution. That is equal to probability of severe pollution when the city is X into probability of X, right, plus probability of severe pollution when the city is Y into probability of Y, plus probability of severe pollution when the city is Z into probability of Z. Now I randomly take the cities, so I can consider. So for this question they will give, right? So in the question they will tell that severe pollution probability. So the severe pollution probability is for severe pollution. So this will be given in the question. Severe pollution probability for each city. For X that is equal to 0.4. For Y that is equal to 0.3, and for Z that is equal to 0.9. Okay, right. Now this information will be given in the question. So after finding out the answer, I will explain you the scenario conceptually. Just look at this one. Right. Okay, now I randomly take the cities. So the probability of X is 1/3. This is also 1/3. This is also 1/3. Okay, right. Now what they have told is severe pollution is also given. Right. Now this means this is 0.4. This is 0.4. This is 0.3, and this is 0.9. Which means when the city is X, the severe pollution probability is 0.4. That is equal to, this one is 0.4 into this one what is this? 1/3. Okay, yeah, 1/3. Probability of X is 1/3. We have already found out. Plus probability of severe pollution. Probability of severe pollution when the city is Y, that is equal to 0.3, that is given in the question, into probability of being Y as the city being city Y is 1/3, plus this one is also given 0.9. 0.9 into this one is also 1/3. Now if you simplify this, you will get the answer 8 divided by 15, that is equal to 0.53. So I have rounded the value to the second decimal place. Now if I convert this scenario to a Venn diagram, so I'm going to pick a city, right? So that might be X, Y or Z. Now all these three cities suffer from pollution, but the level of the pollution might be severe or, like, let's say moderate or whatever, right? There are two possibilities: severe, right? Now if I take a city, its being X is 1/3 because we select the city at random, and it is given, right? So there is probability of, so this is actually probability of S when the city is X. That means this portion, right? Okay, that is 0.4, this is 0.3 and this is 0.9. Now to find out the probability of severe pollution, you have to just add this and this. So you just multiply these two and add with these two, right, and this two. So this is what we have studied under probability. So this is 1/3 into 0.4 plus 1/3 into 0.3 plus 1/3 into 0.9. So the final answer is this one. Okay, so with that question I will explain another question also, right? Okay, now I'm going to take a person called, okay, let me take myself. Right, now E-class uses 3 modes of transport to go to his office. Okay, right, now E-class uses 3 modes of transport, right? And when he uses these 3 types of transport, he might go to the office late. So we are going to take that one. Okay, so I use 3 modes of transport. One is bus, then car, and then train. Okay, right, now I'm going to indicate the probability of going to office late. So let me take, this is the portion, so this is going late. Okay, right, now they are telling 20% I will go by bus, 20% I will go by bus, and 30% I will go by what? Car, and the remaining 20% I will go by train. I'm sorry, remaining 50%. Right? Now if I add these whole probabilities or the possibilities of going to the office, it should give me 100%, or the probability wise it should give me 1. Okay, so 50, 30 plus 20, 100%. Okay, now the probability that E-class reaches his office late is equal to, when he takes bus, that is 0.4, and when he takes car, that is 0.2, and when he takes train, that is 0.1. Okay, so basically it means this is 0.4 and this is 0.1 and this is 0.2. Okay, this is what they have given. Now I need to find the probability of going late. The total probability of going late is equal to probability of going late when he uses bus into probability of going by bus, plus probability of going late when he takes car into probability of taking car, plus probability of going late when he takes train into probability of taking train for going to his office. Now this is very simple, right? So this is given. So this is actually 0.4. When he takes bus, going late is 0.4. This is actually this portion. 0.4 into this one 20 percentage means 0.2, right? So 20 percentage means that is 0.2, and this is 0.5, and this is 0.3. Okay, so I have converted these percentages to decimal values. Plus probability of going late when he takes car is 0.2 into probability of going car is 0.3. Otherwise I can use 30 divided by 100 also. Okay, plus going probability of being late when he takes train is this portion 0.1 into taking train is 0.5 or 50 divided by 100. Now if I simplify this one, I get the answer as 0.19. So what this means is 19 divided by 100. Okay, so out of the 100, the probability is 19, right? So out of the 100 percentage, 19 percentage he goes late. Okay, right. Now if I convert this into a tree diagram, this will become like this. I can take bus, car or train. Now I can go late or on time. I can go late or on time. I can go late or on time. Right, now this is 20 percentage, this is 30 percentage, and this is 50 percentage. Now if I take bus, going late is, this is given 0.4, this is also given 0.2, this is also given 0.1. So for finding out the total probability of going late, I have to just multiply this plus this plus this. So that is the idea. Okay, so I have explained the total probability and I have done two examples over here, and I will directly move to the the past paper questions held in 2019. Okay, so I have my past paper book with me, so let me read the question and explain. Right, now this is going to be the answer for the 2019 question 17A. 2019 August 17th A, right? Okay, they are telling initially a box contains 3 balls in all aspects except for their color, each of which is either white or black. So a box contains 3 balls, okay, and the 3 balls are identical in all aspects except their color. Only the color differs and the rest of the properties are same. For example, size, shape, whatever it is, they are same, only the color is different. So they might be either white or black. Okay, they might be either black or white. Now, okay, if I read continuously, now one white ball identical to ball in the box in all aspects to avoid bias in the box in all aspects except for its color is added into the box, and then one ball is drawn at random from the box. Now what they are doing is, okay, from outside they are putting another white color ball. So no, I don't know whether this ball is white or black, this ball is white or black, this ball is also white or black, but definitely I know the fourth ball added to the box is actually, or definitely that is white. Okay, right. Assuming that the 4 possible initial composition of the balls in the box are equally likely, or find the probability that the ball is drawn white. Now they are telling to find out the 4 possibilities, right? They are telling to find out the 4 possibilities. Right, now I have 3. Okay, I have 4 balls, right? So this is ball 1, this is ball 2, this is ball 3, this is ball 4. Definitely the fourth ball is white, but this might be white, this might be black or black. This is a possible scenario. and yeah, right. Now this might be white, this also might be white, and this might be black, but definitely this is white. Okay. And another possible scenario is this might be white, this might be white, this might be also white, but this also white. And another possibility is now they are telling these three balls are either white or black. So no, all these three balls also might be black. So this is also another possibility. Black, 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 but this is white. So these are the four compositions that are possible for these four balls. Now we have to find out. Okay, so let me think this question conceptually. So out of the past paper question, this is a bit complex question, but if you look at the previous past paper questions, those might be very easy when compared to this question. Okay, now let's assume I take a ball. So this ball, now after putting it, we have four balls all together, right? Now I can take this ball. Okay, so this ball and this ball, this ball and this ball, right? Now the probability of taking one ball from the box is 1/4, 1/4, 1/4, 1/4. Okay, right. And in addition to that, if I take the ball, that might be white or black. This might be white or black. Now this also might be white or black. This also might be white or black. Okay. Now if I take this scenario, okay, these are the four possibilities. Now if I take this scenario, now I have taken a ball. The probability of being white is 2 divided by 4, and the probability of being white is 3 divided by 4. Now the probability of being white is 4 divided by 4. Now the probability of being white is 1 divided by 4. Now let's assume, okay, so if I take this one, okay, now let's assume all the three okay, initially let's assume this scenario, all the three balls are black color. So the taking, okay, I have, after taking a ball, now it should be white. The probability is 1/4. Okay, so that is 1/4. Now let's assume only one ball was initially with white, only one ball, and I have added another ball. So the probability of being white is 2 divided by 4. So this is 2 divided by 4. And let's assume initially the box contained two white balls. Now I have added another one. So the probability of being white after drawing a ball is 3 by 4. And again this scenario 4 by 4. So now I have to write probability of being white is equal to probability of white. Now let's say this is composition C1, this is C2, this is C3, this is C4. Okay, so composition 1, composition 2, composition 3, composition 4. So probability of being white when the composition 1 into probability of composition 1 plus probability of, so otherwise I can write, so Ci is equal to Ci, I am going to denote the composition as Ci. A starts from 1 to 3, I is equal to start 1 from 3, but you can write in any other way, right? So you can use summation symbols and do, otherwise you can just write the equation like this and do the questions, right? Probability of being white when the composition 2 is selected into probability of composition 2 plus probability of white when composition 3 is selected into probability of composition 3 plus probability of being white when composition 4 is selected into probability of composition 4. So I just want to substitute, right? Okay. Probability of being white when the composition 1 is selected, that is 2 by 4, 2 by 4 into probability of C1. So composition 1 is, that is out of the 4 we have 1 by 4 plus again 3 by 4 into 1 by 4 plus 4 by 4 into 1 by 4, then again this 1 by 4 into 1 by 4. So if you simplify this, you get the answer as 5 divided by 8. 5 divided by 8. Okay, so this is the question. And in the B part, initially there were exactly 2 black balls in the box given that the ball drawn is white. So they are telling to use the Bayes theorem, right? So this is directly the application of Bayes theorem. So what you have to do is, let me erase this part. Now they tell, find the probability. Initially there were exactly 2 balls in the box. So they are telling initially this one, right? So probability of C2, okay, when it is given, it is given that the probability white ball is drawn. So when the white ball is drawn, probability of B initially, then okay, now this is the scenario. Now we have found out the probability of being white, and they are telling, now we have taken a white ball, we have found out the probability of total white ball, and initially there should have been 2 white balls in the box. That means they are telling, at least, or initially, initially means you have to just put this one, initially 2 balls. Initially there were exactly 2 black balls. I'm sorry, there were 2 black balls mean, you have to read the question very carefully. 2 black balls mean initially in this first composition only we have initially 2 black balls. So you should have, if you have misunderstood the question, or if you have taken this composition as I did, you will end up with a wrong answer. So they are telling initially there were exactly 2 black balls in the box given that the ball drawn is white. So probability of composition 1, okay, composition 1, when provided that we have already taken white color ball, is equal to probability of white into, we have to just put this one, probability of white C1 into probability of C1. So we have already found out this one. Where is this? This one. Here. This one. Okay. So we have already found out this one. Okay, you can see, I think. This one. So that is equal to 2 by 4 into 1 by 4 over total probability 5 divided by 8. If you simplify, you would get the answer as 1/5. So I hope you have understood this question. In this video, I have explained you the total probability, and I have done 2 examples to make you understand the total probability, and ultimately I have done the latest past paper that was held in 2019. Okay, thank you. I will meet you in another video.